the foundations for AI. Better connectivity, cheaper processors, portable computers, the explosion of social data, Internet of Things, leading to big data, the cloud backed up with blockchain. That's how we got from there to here, and we got to IT Phase 3, which are systems of insight. Systems where we can take that explosion of data and make sense out of the data in which we are drowning. And also solve the paradox of choice for consumers where there's simply too much to understand. That's where we are today, systems of insight, systems that can simplify. So if we look on one side, we have cloud and mobile and blockchain and cheap computing, ubiquitous connectivity. On the other side, big data, IoT, smart everything, paradox of choice, stalled conversion rates. Maybe AI can bring problems together and solve them. So today we have all kinds of AI APIs, from leap learning to neural networks to expert systems, facial recognition, inference engines, an explosion of AI solutions. And that didn't happen overnight. People have been working on this for quite a long time, as you saw in the timeline. 10 years ago, Google created Image.net. They curated 1 billion images. And then they hired 50,000 people through Mechanical Turk to tag each of those images. That was 10 years ago. This year they announced that while humans have a 5% error rate in identifying the contents of an image, computers now have a 4.8%. So machines are now better than people at understanding what's in an image, which means we can use a system to pick exactly the right image to show to just the right consumer at precisely the right moment. That's a big change. So I think AI is a game changer. And there are several reasons why. The first one is it can take unstructured data and make it structured. So it can make sense out of unstructured data. It can read 1 million medical records and look at the X-rays overnight and begin to do diagnostics, right? We already had the ability to analyze financials of companies, but now systems can read 2 annual reports and tell you the difference in tone in the chairman's letter. Is the chairman a little more worried from the tone of the letter? The machine can tell you that. Secondly, these are learning computers. This is a very important part of AI. These are learning systems. They're the first computers that are worth more when they're old than when they're new. And as an old guy, I like that very much, right? They're wise. So that's why they're concentrating on gaming, right? Moving from chess to Watson playing Jeopardy to Deep Blue playing Go, which has more solutions than there are molecules in the universe, but we now have a system smart enough to win at Go. They do that because there's learning. So if you walk away with nothing else tonight, walk away thinking about learning systems. So we're all hearing about self-driving cars. So when your son has a wreck and you chew him out, right, most likely he learned how to not have that wreck again. When a Google self-driving car has a wreck, all the other Google self-driving cars in the world learn how to avoid that accident in a week. Tesla gets 1.5 million miles of daily data. From my Tesla, which I don't use self-driving very much, all those sensors and all those cameras are feeding data to Tesla every day to get smarter. So learning systems are a big change. It's 24/7 by 365 going to school. That's what these systems do. Now, they're not perfect yet. You may have heard what happened when the Google self-driving car went to a 4-way stop, and it waited for the guy on the right who left, and then the guy on the left pimped it, and the guy in front of him pimped it, and the Google car never moved because everybody was doing not exactly legal things, and the car didn't know what to do, so it just stayed there for like 3 hours until somebody came and saved it, right? And, you know, what happens when you honk at a self-driving car? Is it going to wave or maybe make some other hand gesture at you? You know, who knows, right? What's going to happen? There's more training to be done here. But learned systems can give advice, and that is different. So that's number 3. Watson, for example, says 95% chance this is the treatment for this patient. And finally, they understand natural language. So if it says, I want to go to Italy this summer with my family, it knows Italy is a country and summer is a season and family is a bunch of people who live together and are related, so it can answer that question. Or maybe they do, right? So, make sense of unstructured data, offer advice, speak in natural language, and learn. That is a game changer in my book.